Alright, today we'll be learning about scientific notation. This is a topic that you will learn a lot about in the future, and it will clear up some of the questions you have. Like sometimes you've typed something into your calculator and you get something like 2.8653 E 51 or something, and you're like, Mrs. Schoberg, my calculator messed up. I have no idea what that is. Well, today you're going to learn what that means and more. So, scientific notation. Scientific notation is a shorthand way to write very large or very small numbers. A lot of times when you're talking in science, the numbers you encounter are either really big, like, hey, I wonder how far away the nearest star is, or very small, like, what's the diameter of an atom? So scientists wanted to come up with a shorthand way to write these very, very large or very small numbers to make it less cumbersome. So a number is in scientific notation if it's written in this form. Okay, definitely write this in your notes. Okay, it has to be in the form a times 10 to the n. So a is just a number there. N has to be an integer. And the special thing about the number a in front is a has to be between 1 and 10. The absolute value of a has to be in between 1 and 10. It can be equal to 1, but it has to be less than 10. So a could be like 8. It could be 3.4. It could be 1. It could not be 10, though. It could be 9.6. So basically, I like to think of a as a single-digit number. It could also be a negative, like negative 2.7 would be fine as long as the absolute value of a was between 1 and 10. So if I'm going to ask you if something is in scientific notation, and then we'll get over to more like what does that number actually mean, I just want you to look and see, is it in that form? A times 10 to the n. A has to be a number in between 1 and 10 or equal to 1. And there has to be 10 to a power. So I want you to try to do this before I say yes or no. So is the number written in scientific notation, yes or no? And if not, explain. So 0.46 times 10 to the fourth. Okay, it does have a number times 10 to an integer of a power, but that number at 0.46 is less than 1. So this is not in scientific notation. So no. Okay. I see 3.25 times 10 to the negative 2. Okay, try that one on your own. Oh, and try the next one too. 13.2 times 10 to the negative 5. Okay, if you looked at the second one, said, hey, yep, that number's in between 1 and 10. This is 10. This is an integer. It follows everything about the form, so that one should have been yes. 3.25 times 10 to the negative 2 is in scientific notation. 13.2 times 10 to the negative fifth. Well, here we've got a 10 here. This is an integer. But 13.2, that's bigger than 10. It does not follow the right form. So 13.2 is larger than 10. So it's not in scientific notation. So, no. Okay. Let's look at some powers of 10 and kind of see if we can figure out some patterns and what they mean. Well, let me actually get a new slide. Okay, if I started here and I was asking you about some powers of 10 and I said, let's look at 10 to the first, 10 squared, 10 to the third, 10 to the fourth. I'm sure you all know that 10 to the first would be 10. 10 squared would be 100. 10 to the third would be 1,000. And you would probably figure out 10 to the fourth would be 10,000. And if I ask you 10 to the 0, I hope you would remember from yesterday that that equals 1. So 10 is pretty cool because that's the number base that we work in. So all that happens when we multiply by 10 is we start here at 10 to the 0, just at 1, and we keep moving the decimal over. So by 10 to the fourth, we've moved the decimal from our original 1 of 10 to the 0. We've moved it 4 times to the right. If I looked at some negative exponents, I want you to notice that something similar is happening here. If I do 10 to the negative 1, we know these are reciprocals, 10 to the first and 10 to the negative 1. So that's 1/10. If we write it as a decimal, it becomes 0.1. 10 to the negative 2 is the reciprocal of 10 squared, so 1/100th. If we write that as a decimal, 0.01. 10 to the negative 3, that's 1/1000th. And again, 0.001. So I want you to really look at this. If we started with 1 as our original base, to get to 10 to the negative 1, I move the decimal left 1 time. To get to the negative 3, I move the decimal left 3 times. Okay? So 10 to the negative 3. From 1, we moved it 3 times to the left. That's why we like to multiply by 10, powers of 10, because it's such an easy number to work with. All that we really have to deal with is moving the decimal. So if we're looking here and we're trying to write some numbers in scientific notation, we'll start with this one, 234 million. Okay, so when you're trying to write a number in scientific notation, we have to say, first of all, where do I put the decimal to make this number in between 1 and 10? So you can kind of be like looking along and say, I wonder where that decimal should go. It should be before the 2, after the 2, after the 3, after the 4, blah, blah, blah. Well, we should notice it should be after the 2 if we want that number to be in between 1 and 10, because 2.34, that's in between 1 and 10. And we can have all those zeros at the end, but they don't change our number. So then what I like to think about is our decimal. If we want our decimal to be at 2.34, but we need to see how many times we actually have to move it to get to the real number, because we want to see times 10 to what power equals our 234 million. So I'm going to look 1, 2, 3, 4, 5, 6, 7, 8. To get to the end of my number where my decimal really is in the 234 million, I moved it 8 times. And I moved it to the right and made it bigger. I made it a big number, so it's going to be times 10 to the 8th. Okay, so 2.34 times 10 to the 8th is how to write 234 million in scientific notation. If you have a next number here, 0.0000, I don't know if I said the right number of O's, but 4 zeros, 6 threes, 6-3. Again, you want to first look and say, where do I need to put this decimal to get it in scientific notation? Well, I need to put it between the 6 and the 3. Okay? And you're like, if I want it there, how many times do I have to move it to get it where it actually is? 1, 2, 3, 4, 5. But this time when I moved it 5 times, I did not make it a big number. I made it a tiny number, a small number. I moved it to the left. So it's times 10 to the negative 5th. So 6.3 times 10 to the negative 5th means 0.000063. All right, let's practice going the other way. So this time, I'm giving you numbers that are in scientific notation, and I want you to write them in standard notation, so just like a decimal number like we normally have. So we have here 8.8 times 10 to the 4th. So we're going to start with 8.8. And 10 to the 4th, that's a big number, okay, 10,000. It's going to signify I'm going to make this a big number, and I'm going to move my decimal 4 times to the right. So I'm going to start at 8.8. I'm going to go 1, 2, 3, 4. Our decimal will now be here at the end of our number, and within our gaps, we want to fill in zeros. So this elephant weighs 88,000 kilograms in standard notation. Okay. If I'm looking for an ant's mass, an ant only weighs 7.3 times 10 to the negative 5 kilograms. So this negative exponent is going to say, I'm going to make a really tiny number. I'm moving my decimal place to the left. So 7.3, now I'm going to go 1, 2, 3, 4, 5, put my decimal in, add in the zeros. So I would have 4 zeros, 7.3 kilograms. That's how much my little teeny ant would weigh. Okay. Sometimes you're going to work with these numbers to use some ordering and comparing. So if I ask you to list the planets in order of their distance from the sun from least to greatest, well, maybe you learn the same song I did in kindergarten or 2nd grade or whatever. Mercury, Venus, Earth, and Mars, etc. And you know the order, but let's just play around, pretend we don't know the order, and let's look at the numbers. Okay, what is good about these numbers is that they are all already in scientific notation, which makes it pretty easy to compare. because if it has moved over 10 to the 7th, that's going to be a smaller number than when it's moved over 10 to the 9th, providing we're talking about positive numbers here. So if we're saying least to the greatest, we need to look at the ones that have the smallest power first. So 10 to the 7th and 10 to the 7th. Of those two, Mercury is only being multiplied by 3.8 and Earth's being multiplied by 9.3. So it looks like Mercury is the closest to the sun. Okay, that has the smallest distance away. Earth would be second because it's also 10 to the 7th. Then looking at next, 10 to the 8th, Jupiter would be third. And last, Neptune has an exponent of 10 to the 9th. Neptune's the furthest away here. Okay. Sometimes, though, you're given numbers that are not already in scientific notation or standard form. So, like, these are hard to compare because 0.063 times 10 to the 5th is not in scientific notation because 0.063 is less than 1, okay? So we need to do one of two things. We can either make them all in standard form or all in scientific notation. You need to get them all into one form or the other. Most students that I've met, at least with small-ish numbers like this, they prefer to go to standard form first because you're more comfortable with it. So let's try that in this example. So I'm still going to move my decimal 5 times to the right. So 1, 2, 3, 4, 5. I've added 2 zeros. So 6,300. That's that first one. This I'm going to move it 4 times. 2, 3, 4. I'm again adding 2 zeros. This time it's 60,300. 6,103 is already in standard form. And 63.1 times 10 to the third, so I'm going to move it 1, 2, 3. I'm going to add 2 zeros there. 63,100. So we can kind of see that least is this one, 6,103. Second least is this one, but when I list it, I want to go with whatever it showed me first. So 0.063 times 10 to the 5th is the second smallest number. Then 60,300. So that's going to be 6.03 times 10 to the 4th. And then finally, the last one, 63.1 times 10 to the 3rd. Okay, all in mixed up notations there. Okay, here's the last thing we're going to do. We're going to simplify and we're going to write our answers in scientific notation. So what I think is key to note here, this means 6 times 8 times 10 to the negative 4th. There are parentheses around 10 to the negative 4th, but notice all of this is multiplying. So the first thing I want you to notice is, okay, multiplying order doesn't matter at all. Okay, if all we're doing is multiplying, we can multiply in whatever order we want and we're going to get the same answer. So I'm going to multiply 6 by 8 first. And I get 48 times 10 to the negative 4. Now it says I need to write my answer in scientific notation. So this is not in scientific notation because 48 is bigger than 10. So I want to figure out where I need to put the decimal point there. And that's going to be 4.8. Okay, but I moved the decimal 1 time. Okay, this is how I like to think about it. Since I already moved the decimal 1 time, I need to change the power of this exponent by 1. And how I like to think about this, I made this number smaller. So to make it balance out, I need to make this number bigger. Otherwise, it will not equal the same number. So 10 to the negative 4, I move the decimal 1 place, so I'm going to change this by making it bigger by 1. Should equal the same thing as 4.8 times 10 to the negative 3. Okay, and you can check that on your calculator or what not. Okay. This next one, 0.3 times the quantity, 1.3 times 10 to the third. Again, we're multiplying the whole time here. So I'm just going to multiply in whatever order I want. And I'm going to multiply 0.3 by 1.3. Okay, and that time I'm going to get 0.39 times 10 to the third. Okay, now again, that's not between 1 and 10, so I'm making it 3.9. Look, I made it bigger, so I want to make this exponent smaller. And it should be 3.9 times 10 squared. Okay, so think about this. and have a great day.